Greetings and welcome, friends. Mr. Waddy here. We were solving multi-step inequalities. They pretty much behave nearly identical as solving equations, similar properties. The only thing we had to keep an eye out for was multiplying or dividing by a negative would be when I'd flip the sign. So let's see, 5y plus 9 to get y by itself. We'll deal with the addition first. The inverse of addition is subtraction. I got subtract 9 from both sides. Do not have to flip that inequality. And so I'd have 5y is less than or equal to negative 5. And then I could divide both sides because the inverse of multiplying by 5 is division, like so. And wait a minute, do I have to flip the sign? This has a minus sign in it, and there's dividing happening. What are your guys' thoughts? No, Mr. Waddy. That's right. Because we were dividing by positive numbers, and this minus sign in the numerator we don't care about, it will not have to flip the inequality. And so to giraffe that, I'd have 0. Negative 1 is to the left of 0, and this would be a closed circle shaded to the left. All right, man. Whoever that student was, they knew what they were talking about. Over here, let's see. Oh, Amity, you're going to walk me through this one? All right, yeah, give it a try. That's all we got to ever do. Right, because that 3 is positive. So subtract 3 from both sides. I agree. And let's see, I'll catch up to your thinking here. So r divided by negative 4. All right, so now what do you think we should do? Right, since this was division, the inverse operation is multiplication. So multiply both sides by negative 4. And wait, we just said multiply a negative. Well, I multiplied both sides by a negative 4, so that means I'm going to have to flip the inequality, right? Yeah. No, it's whatever I'm doing to both sides. If that's negative, that's when I flip it. So let's see, then 0, 12, negative 12 is to the left of 0, and so we'd have a closed circle shaded to the right. Is that a hand up question that I'm seeing, or? All right, it would be in a different sequence. It should be in the kind of second to last page on the 2.4 packet, I believe. Yeah, sorry. I don't know. Let's take a look at, all right, second to last page. We got a confirmation here. Ooh! I picked a funny one with these cursive-looking L's. All right. Oh, we're getting a confirmation that nothing works for this problem. Let's find out. Let's find out. So I distribute to simplify as starters. 6. What? That's like a cursive L. So 6L plus 18 is less than 6L plus 3 times 6 is 18. Okay. And now I bring the L's together. One thing, by the way, I've noticed recently amongst our class's work is that when you bring variables together, sometimes people are doing this. And that, what is the no-no about that? Does anyone know what the error is? Yeah, Cameron, yeah? There's no L. Yeah, we're subtracting 6L from both sides. And when students have dropped that, then I often see a mistake on the very next step, or they might even write -6 under something that wasn't a like term with those L's to begin with. So those cancel out, those zero out, like Pooja was saying. I've got 18 is less than 18. Now, is that a true or false statement? That's so false. But 18 is the same as 18, but it's not less than itself. So that means there is no solution. There's no number that will ever make this inequality true, no matter how hard we try. All right, so that one's kind of interesting. And yeah, definitely make sure you're careful with your work steps. By the way, I work with multiple colors because I think it's helpful and easily interpreted. If you want to do your algebra with like your work steps in one color like I do with the orange and your like result steps in yellow or whatever other color, it's not a bad idea. It might really help some of you organize your work a little bit better. Oh, wow. Look at this one. All right. I'm gonna check in with my friend Ethan on this one. He knows what he's talking about with algebra. What do you think I should do as my first step, Ethan? I don't know. Even if you have a different step, then maybe I might. Yeah, so I agree. We would distribute over here. So that's going to be still greater than or equal 3 times 5j is 15j, and 3 times negative 2 is negative 6. Anyone have ideas as to what over here I could do, if anything? Yeah, bring those like terms together. They're on the same side, so I don't have to subtract them or nothing. But 9j plus 6j is 15j minus... Oh, wait a minute. It's happening again. What? Let's bring our variables together. To move a 15j to the other side, I've got to subtract 15j. All right, so make sure you write that j there. Let's see, I'll even make sure he gets his little dot. There we go. So 15j minus 15j cancels out. And also, don't just assume that because you did something to both sides that it's actually canceling out. Make sure it actually makes sense. Like 15j's minus 15j's is 0. Sometimes if you write the wrong sign, if you took the time to look at it, wait, 15j plus 15j is not 0. That would be 30j, right? And so make sure you just kind of think about it as you're doing it. Don't have to flip the inequality for that. Oh, is this a true or false statement? It's true this time. Because it's got that equal part, that is true as blue, or green in this case. Negative 6 can equal itself, and so that means that this has, let's see, infinitely many solutions. That means every real number that I could plug in for j here will work for this problem. Todo, everything. All right, everything, maybe. You might even say it that way. All right, let's see. Do I have the cool... Oh, I do. Look at this. Here's an area problem. Okay. Now, some of you might have left this one blank. Let's do this together. It's all right. It's all right. This done be a rectangle is what this looks like. And it says the area of the rectangle is greater than... Ooh, that sounds like is greater than. That's a relationship. 60 square feet. So for my equation part, I'm going to say something is greater than... Oh, not equal, just greater than. 60 is what's happening there. It says write and solve an inequality to find the possible values of x. So my variable here, they actually just gave me one. My variable is just like possible values of x. So I'm just going to let x be my variable. I don't even know how to represent it more than that. Let's see, for our inequality, this is actually going to require me to bring some knowledge to the table. What is the area of a rectangle formula? Base times height, length times width, length times height, whatever you want to call it, right? And so I'm going to call this my base and this my height. And so if the area is greater than 60, that means the base times height is greater than 60. That means 12 times this is greater than 60. So let's actually write that out. I'll write it in green, I suppose. Yeah, so I'm pulling this information and this information to write this inequality. So 12 times 2x minus 3, the quantity 2x minus 3. Everybody in parentheses there. There's my inequality. Usually, students have a harder time interpreting a word problem into the equation or inequality. But once I have this, I know you guys are expert solvers here. What could I do to solve this? Yeah, let's distribute to both sides. Last class, I said, what in distribution? And that was classic. And then a kid made a meme out of it. This is amazing. Man. 12 times 2x is 24x. 12 times negative 3 is negative 36, greater than 60. Okay, let's keep solving this. Let's get that x by itself, because that's what I want to find out. Like, what could the value of x be so that the area of this would be bigger than 60? What do I deal with first here? I like that. Add 36, both sides. Do I have to flip that inequality? No, I do not. Let's see. That's like 96, I'm guessing. I like it. Oh, thank you. Actually, yeah, I was just going to be wondering what that was going to be. So x is greater than 4 is my solution. And this one didn't have as interesting words. I didn't have units for x. The dimensions of the rectangle were in feet, but x wouldn't really have been in feet. X is just a number. So the answer would be x is greater than 4, I guess. Yeah, nothing really more to say about that. So thanks for watching, internet friends, and be careful when you're solving inequalities with rectangles.